Hi guys, this is Michael from Bird Channel, and today we're going to talk about AP Stat Unit 1, the very fundamentals of statistics. Let's dive in. So to start with, statistics are collecting, analyzing, drawing conclusion from a dataset. And in statistics, there are two kind of main factors that influence the statistics. The first one will be the individuals. The individuals are the thing that we measure, like the people, the animal, thing, or like bunch of objects. And the second factor would be variables, which is the characteristics of individuals. So for example, when we're calculating about COVID, the individuals would be how many people are getting the people who are getting affected by COVID, and the variable will be the COVID itself. And for variable, there are four kinds of variables. The first one would be the discrete variable, which means that it's a fixed set of possible numerical values. And this means that when we count numbers of human, we usually count it as one person, two people, three people, four people, like that, right? There's no such thing called 1.5 people. That's the reason why we count number of human as a discrete variable. The second variable is the continuous variable. Continuous variable is any value in interval possible. This means that when there's an interval, something like a 1 to 5, then 1.2, 1.4, 1.6, everything is possible. And usually the biggest example for this would be the temperature, like the Fahrenheit, because for Fahrenheit we can measure 69.4 Fahrenheit, 69.8 Fahrenheit, and other many stuff. The third one would be the categorical variable, which means that they're assigning a label that groups individuals. This just literally means variables that can be considered as categories. The fourth one would be the quantitative variable, which is the numeric values, such as number of siblings. So there are some overlapping variables between all these four variables, but yeah, these are the definitions for these. And there's another vocab that we should know, and the vocab is frequency, which means the count. And the relative frequency is the percent or proportion of those counts. So for example, out of 100 people, there are 50 people who are sick. Then the frequency would be 50 out of 100. And the relative frequency would be 50%. The next vocab will be just a bunch of tables and graphs. So the first table that I'm going to introduce are pi table and bar graph. These are usually used for representing categorical values. And for pi table, those are the tables that look like this. That looks like a circle, and you divide it like these kind of lines, and you write something such as 20%, 10%, 5%, da 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 da, and etc. The bar graphs are just a graph that you know, like the graph that you draw as a bar graph. These are the bar graphs. And this table, which we call as two-way table, will be the most important thing that you should know in AP Stats. So in two-way table, it is usually represented as one variable over here and the second variable over here. It sometimes changes, but usually it's like this way. And these each block represent that they have these two characteristics. It means that for number one, it means that that count of people has the characteristic of large capital A and small a. And for 5, it means that it has B and beta, and for 9, it has C and delta. And these are like the total counts that we write down on the side. And this is a little bit going deeper about the relative frequencies. So for relative frequencies, there are three kinds of relative frequency. The first one is the marginal relative frequency, which are simply which would be represented as this form. And there's a joint relative frequency, which means this kind of thing. So this joint means that two characteristics are joining together, which is A and alpha. And if we look at the 2A table, A and alpha is 1, so that goes to 1 over 21, which is the joint relative frequency. And the conditional relative frequency would be something such as A given alpha or alpha given A. These are the ones that we call as conditional. And the reason why I wrote 1 over 6 is because out of all alphas, we have total 6 alphas. Only one is 1 corresponds to A. That's the reason why I wrote 1 over 6. Because there's 6 alphas and there's only one A. So we're representing as like this. So these are the 3 relative frequency that we use as in two-way table. The next thing would be the side-by-side bar graph, segmented bar graph, and mosaic plot. This is going to be represented in your textbook, or you can just simply search it up because it's a really simple graph. And it doesn't really appear a lot in AP Stat exam. But you should know how they look like. And the next vocab that appears in AP Stat Unit 1 would be the association. Association means that if knowing one value helps predict the other, we say that they are associated with each other. Now let's move on to dot plot. Dot plot, this is the second most important plot that you should know in AP Stat. Most of your AP exams, there's gonna be two-way tables and there's gonna be a bunch of dot plots. So dot plots are just representing your data as a dot. So for example, if this is a people, this is like a people infected with a disease named alpha. Then this y-axis will be the count or number or frequency. Oh, my bad. It's not infected with alpha, it's just infected. In our world, there's gonna be a bunch of disease, right? There's gonna be like a cold, flu, COVID, Ebola, it's like sore throat, headache. Let's just change these into simple stomach ache and joint pain. I don't know. Joint pain. So if there's only 3 people who got cold, we represent it as 1, 2, 3, 3 dots. If there are 5 people who got flu, it's gonna be something like 1, 2, 3, 4, 5. When we say there's 20 people who got stomach ache, it's gonna be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Like that. If there's like 6 people who got joint pain, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And this is going to be a dot plot. So they're simply representing the frequency as a dot. But you're counting the frequency of each categories. So for example, in our categories, the category was the people who got infected by certain disease. And our categories were cold, flu, stomachache, joint pain, sore throat, headache, and yeah. And these kind of dot plots sometimes make a certain shape. And those are the shape that we have to focus on. So the first shape would be skewed right. The second shape would be normal, which we also call symmetric. And the third shape would be skewed left. Skewed right means that they have a long tail on the right side. Skewed left means that they have a long tail on the left side. And normal, which is symmetric, means, yeah, literally symmetric. And the shape, variability, center, and the characteristics of these dot plots describe their patterns. And there's also something called an outlier. So as you can predict from the meaning of outlier, outlier means that observations that lie outside distribution. So outliers are something that's located over here. So this is an outlier because it does not correspond to any of the dot plots, but it is a data set that we have to count. That's the reason why we call it outlier. Now we're going to move on to something called stem plot. So stem plot is basically when you have a number such as 21, you separate the first number and the second number, and you put the first number over here and the second number in this part. So this is basically 1 to 9, and this is gonna be 10, 20, 30, dot 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 dot. So if you see a stem plot that has 1 over here and 1, 2, 2, 3 over here, then it's gonna be something like 11, 12, 12, 13, 28, 29, 30.